Matrix representation. So first of all, we need to understand what a matrix is. A matrix is something that is in square brackets. Okay, it has an order. Order depends on the rows by the columns. Don't multiply it, we just leave it. So this one here is 3 rows and 2 columns. That's a 3 by 2 matrix. That's its order. The numbers inside the matrix are known as elements, and each position is given a particular number, so to find it. So this one, because it's row 1, 2, 3, and then column 1 and column 2, this number 2 is represented by little a because the matrix is big A, so little a is all the elements, and it's row 1, comma 2. Sometimes I might write it as A1, comma 2. It doesn't matter. You don't need to put the comma in, but that's very important. While this one here, this one is little a because, again, it's matrix A, and this is row 3, column number 2. So that's how we read these. There's a few more examples here of how we can do it. We've got row matrix. A row matrix is just a matrix that's written in a row. Doesn't matter how many columns it has. This one is a 1 row by 3 columns. It's still a row matrix. We can have a column matrix. A column matrix is in one single column. Again, doesn't matter how many rows there are this time. A square matrix, as the name suggests, a square must mean it has the same number of rows and columns. They have to be equal. It's the only way you can have a square matrix. So this one here, matrix D, is 3 by 3. Matrix E is 2 rows, 2 columns. They're both square matrices. Okay, switching rows and columns, the transpose of a matrix. What the transpose of a matrix does, and we can do this on the calculator, but you can do it really very quickly in just freely. We make the row become a column. That's what we're doing. We're swapping them over. So here we've got a row, but that row becomes a column. Then we've got this row, 3, 4, and becomes that column. 5, 6, becomes that column. This one is just one row, 1, 2, 3. It becomes one column, 1, 2, 3. How do we distinguish between the matrix? How do we know that we have to transpose it? We put this little t, and that's what we look for on our calculator. Okay, example 1 says, here's a matrix, write the type, the order, and the number of elements. Okay, this one here, you can see there's 3 rows and 3 columns. So I'm going to do the order first, 3 by 3. That means there's 9 elements in there. And the type is a square. There's 3 rows and 3 columns. B, 3 rows, 1 column, there's 3 elements. And this one, you can tell, is just one single column. C, this is 1 row by 1, 2, 3, 4, 5, 6 by 6. There's 6 elements, and this one, of course, is a row matrix. The example 2 for the matrices A and B, write down the values. So we have to look. This one is A, which means it belongs to matrix A. Row 1, column 2 is number 5. A2, so row 2, column 1, -1. A3, 3, third row, third column is number 6. This is B, so we must go to matrix B, third row, column 1. Third row, column 1 is number 1. Example 3. A is a 2 by 2 matrix. The element in row I, so we always distinguish the rows as I and the columns as J, is given by A, Ij equal I plus J. Construct the matrix. So here's going to be my matrix. It's going to be A. It has 2 rows. There they are there. It has 2 columns. There they are there. So now I'm going to find this one here. That one there is given by this rule. You're going to get the I, and you're going to add, so this is row 1, column 1, I plus j is the rule, which is 1 plus 1, which means it's number 2. So that's number 2 in there. I'm just going to write them over here. To find this one here, this is row 1, column 2. So A, 1, 2. Again, the rule is I plus j. That's the rule they give us, which means it's 1 plus 2, which means we're going to get number 3 there. Oops. This one is A, row 2, column 1. So A, 2, 1. I plus j is the rule. 2 plus 1, 3. And this one here is A, 2, 2. So A, 2, 2. Remember the rule, I plus j. That equals I plus j, 2 plus 2. Remember, that's the I, and that's the j all the time, because we write A, I, j, as you can see here. And we just follow the rule, whatever they give us. Example 4, write down the transpose of this one here. So, transpose of this equals, instead of 7, 4 as a row, 7, 4 as a column, and then 8, 1. The transpose of this, 0, 1, 2, 3, 2, 5. The transpose of this one here, 2, 0, 1. Okay, the row becomes a column. Okay, then we've got diagonal, symmetrical, and triangular matrices. Okay, so we know that a square matrix has 2 diagonals, like that and like that. So from left to right, this one here, left to right, is called the leading diagonal. Okay, it says a matrix whose elements are 0 except in the leading diagonal is called a diagonal matrix. So here, there's my leading diagonal. The rest are zeros, diagonal matrix. Here, leading diagonal. Numbers except the rest. Numbers, all the rest are zeros, they are diagonal matrices. Then we have identity matrices. The identity matrices means that the leading diagonal are 1s, and all the rest are 0. These are all identity matrices. They're a particular type of diagonal matrix. Then there's symmetrical matrices, which means that if we look along the leading diagonal, the other 2 numbers are the same, or the other numbers are the same. So it's like a mirror. So here, these 2, you can see the 3 on opposite, the 4, and 5. There's the leading diagonal, and you see mirror image, 2, 4, 5, 6, 5, 6, 7, 7, 8, 8. Okay, so that's what we call symmetrical. Triangular matrices is where we have zeros in a triangle, either down the bottom or up the top. So if you look here, there's my leading diagonal. There's numbers there, but this is 0. So that's called an upper triangular matrix because the numbers are up the top. There's my leading diagonal, and there's the numbers down the bottom. All the rest up the top are zeros. So lower triangular matrix. So they look like triangles. Example 3. Consider the following square matrices. Write down, okay, which ones are. So I'll just go like this. Upper triangular matrices. Okay, upper triangular matrices. So if we look at it, upper triangular matrices, we're going to go for this one here. I'll have to write the matrices. 1, 2, 0, 3 because they're not labelled. That's a 3. The identity matrix. Remember the 1s along the diagonal, so that one there, and there's no other one. A diagonal matrix, well, that one there already, that is a diagonal matrix. And of course we have the other one, the third one, 1, 0, 0, 0, 4, 0, 0, 0, 3. That's a diagonal matrix. A symmetrical matrix is the last one, 1, 3, 5, 3, 4, 7, 5, 7, 2. Which I also believe the other one is also symmetrical, because there's zeros everywhere. Okay, we can do this on the calculator. It's not hard. I'll show you how to do that in our next session, but all you do is you put in the matrix and then you find the little transpose. Okay, and to find the transpose button, you're going to go matrix and vectors and click the transpose. So to put the little T on the top of the matrix, you don't even need to store it, and it will do it for you.